Welcome back, dear students. So let's continue with what we are doing in the last class on differential equation. So in the last class, we were finding the differential equation from a given equation. Okay, so today we have the first question on the screen containing a and b as the two constant. So there are two constants, so that's why the order of my differential equation is going to be 2. Okay, so that means I need to differentiate this twice. So before I differentiate this, what am I going to do is let me keep a and b, that is the constants, to the right hand sides. Everything comes to the left hand side. So you get y minus x sine x is equals to a sine x plus b cos x. Okay, call this as equation number 1. Now differentiate. Okay, so differentiating with respect to obviously x, so y becomes y1 minus, so this is u into v, so u into v is, first differentiate x, so it becomes 1 into sine x plus, now keep x as it is and differentiate sine x, it becomes cos x, right? So a, now differentiation of sine x is cos x. Okay, and this, we have plus b. Now differentiation of cos x is minus sin x. Okay, so let me quickly open the bracket. So it is y1 minus sin x minus x cos x. Alright, is equal to, so we have, this is a cos x minus b sin x. So call this as equation number 2. Okay, now we'll differentiate it again. So differentiating, so let's see what do we get. So this y1 becomes y2 minus this becomes cos x. So let me do it directly. So u into v, if you apply this, so you get cos x minus, so keep x as it is, so differentiate cos, it becomes minus sine, so that's why it becomes plus sin x. Okay, is equal to, see here carefully, so this becomes minus a sin x, this becomes minus b cos x. Okay, now bring everything to the left hand side. Okay, so here you see cos minus cos x and minus cos x gives you y2 minus 2 cos 2x. Okay, now when you bring it out here, you get a sin x plus b cos x and we have ultimately x sin x equal to 0. Okay, so we'll bring it to the right hand side. Okay, now just look at this. So here we have y2. Now how much is this? Just look at this. If you use equation, okay, so this equation, okay, so this is nothing but y. Okay, so in place of this I'm going to write y, sine is plus, so plus y is equals to, now when it goes over there it becomes 2 cos x. I'm sorry, this is not 2 cos 2, this is just 2 cos x. Okay, so we have, this is 2 cos x, so it becomes this much. So we have got, this is my second order differential equation. Now do we have any constant out here like a and b? No, right? So that's why we say this is the required differential equation. Okay, simple. Pause the video and note down your solution. We have another question, so let's take this particular question. So here let's see how to solve this. Okay, so first and foremost we'll call this to be equation number 1. So differentiate this. Here also you see there are a and b, so two constants a and b. So differentiating, okay, so differentiating this with respect to x, obviously, so we have 2ax plus a is kept as it is, so differentiation of x squared is 2x, so this becomes 2ax plus, similarly this becomes 2by, but we need to differentiate y also. Okay, so that's why the differentiation of y becomes y1. Alright, is equals to 0. Okay, So from here, if you divide both side by 2, so you get 2 gets cancelled, 2 and 2 gets cancelled, so only ax is left. Plus similarly you get here b y y1 is equals to divide 0 by 2, you get again 0. So call this as equation 2. I hope you're clear. So you basically I'm applying chain rule out here. Okay, so you remember our differentiation of implicit functions, there we have learned this. Okay, fine. So we got our equation number 2. So differentiating again with respect to x, you have to write it completely. So differentiation of ax is just a plus, now just look at this carefully. So b is a constant, so this is u into v, so first keep y as it is. Now differentiate y1, you get y2 plus, now we'll differentiate y1. Okay, we'll keep y1 as it is. Okay, and we have into, we'll differentiate y. Now differentiation of y is again y1 is equals to differentiation of 0 is 0, we all know. Okay, now we have, okay, we'll keep it as it is for now. So from here we have a plus b, so we have y2 plus y1 square, isn't it? So y1 square is equal to 0, and call this to be equation number 3. Okay, now see, we got our second order differential equation because it contains y2, but it contains a and b also. So we need to remove a and b from equation number 3. So for that I'll be using equation number 1 and 2. I'll solve equation 1 and 2 and find the value of a and b. So for that, what am I going to do is I'll first multiply 2 by x. Okay, so after multiplying 2 by x, we'll find the difference. Okay, so let's do this operation. Basically I'll do 1 minus 2 into x. Okay, so let's do this operation and check what do we get. So 1 minus 2 into x gives, so 1. So in the left hand side we have ax square plus by square in 1 minus, first let's multiply 2 by x, so you get ax square. Now minus is there, so that's why this plus becomes minus, so this becomes bxy y1 is equals to, so equation number 1 we have 1 minus 0 into x is 0. Remember I'm multiplying 2 with x, so that's why 0 into x is 0. So this and this gets cancelled. So from here what do you see? So from here you see that it is b is common. Okay, so in fact you can take by as common. Okay, so we have, okay, for now let me take only b common, so b is common. So from here this is equals to, so we have 1. Okay, now we have, okay, just wait a minute. If b is common, then here you are left with y square minus xy y1. Okay, alright, so you can take y also common then. So we get, if you take by common, then you get y here, and here you get x y1 is equals to, we have 1 here. So from here what is b? B turns out to be 1 by y into y minus x y1. So this is my b. Now let's find the value of a. So for that, you know, you can substitute the value of b in equation 2. Okay, so from equation 2, let's see what do we get. So we have ax plus, we have, okay, so in equation 2 we have b y. So what is b actually? B is 1 by y into y minus x y1, isn't it? So this is my b. So we have y y1, so into y y1 is equals to 0. So similarly you see y and y gets cancelled here. Okay, so take this to the right hand side, and from here the value of a turns out to be, first you take this to the right hand side, it becomes minus y1 by y minus x y1, isn't it? But here remember we have ax, so bring x to the denominator, so it becomes this much. So this is the value of a. Okay, so that's why from equation 3, so therefore equation 3 becomes, okay, so we have a is how much? A is okay, so let me use another color for you. So we have a is minus y1 by x into y minus x y1, okay, plus we have b. So what is b? B is 1 by y into y minus x y1, okay, and we have into this one, so this can be written in the numerator, isn't it? So it becomes y y2 plus y1 square equals to, how much is there? Equals to 0 is there. Okay, so what you can do is multiply both side. Okay, so multiply both sides by xy y into x y1, and let's check how much do we get. So when you multiply by this quantity both side, here this and x and this gets cancelled, so only y is left. So you get minus y y1 plus, okay, so this and this much gets cancelled, so only x is left. So we get x into y y2 plus y1 square equals to 0, isn't it? So it will be better if you open the bracket. So when you open the bracket, so you get, so x y1 square, I'm first writing, I'm sorry, let me write first this part. Okay, so you get x y y1 y2 plus you get x y1 square minus you get y y1 equals to 0. So this is the required differential equation. That's what you need to write at the end. Okay, so you may pause the video and note down the solution. We have yet another question. So in this question, here t is the parameter. Okay, so this is a kind of parametric equation. So basically we need to differentiate x with respect to t, and here you need, see, in such kind of cases, okay, in such kind of cases you will treat only a and b to be the constant. Okay, so a and b are the constant, so p is just a number. Okay, it's just a number. Like if you can take p equals to 2, that will be better. Okay, so it will be like cos 2t minus b. Okay, so don't treat p as a constant, only a and b has to be treated as the constant here. Okay, so in that case, let me call this to be my equation number 1. So differentiating, in this case, let me write it fully. Differentiating 1 with respect to, this time you need to differentiate with respect to t. So you get x becomes x1. Okay, so x1, so a is a constant, so this becomes minus sine pt minus b. Okay, but as per the chain rule, we need to differentiate inner part also. So differentiation of pt becomes p, and the differentiation b is 0, so just write p here. So from here you get x1 equals to a, okay, so it will be minus ap sine pt minus b. Okay, call this as equation number 2. So we'll do the same again. So differentiating 2 with respect to t again. Okay, so when you differentiate with respect to t, this x1 becomes x2 second order. This becomes, so minus ap is a constant. Okay, now differentiate sign, it becomes cos pt minus b into, as per chain rule, differentiate pt minus b, it will be just p. Okay, so p into p becomes p square. Okay, so it becomes x2. So let me write minus p square first, then we are left with a cos pt minus b. Okay, now look at this and look at equation number 1. So from equation number 1, this part is nothing but x, isn't it? So from here we get x2 equals to minus p square. So this is x, isn't it? So from here, you bring this out here, you get x2 equals x2 plus p square x equals to 0. So this is the required differential equation. And remember, here you are, since you are differentiating with respect to t, x1 is dx by dt and x2 is d square x by dt square. You need to keep this thing in mind. Okay, so you may pause the video and note down your solution. We have yet another question. So here, okay, so I want you to do this problem by yourself. Okay, I'll just give you the hint here. So what you are going to do is, first and foremost, you do this. If you bring it out here, you get e to the power x y is equals to a cos x plus b sin x. Okay, and that's what you get, and call this as equation number 1 and do the rest. Okay, so I'm leaving it for you to do by yourself. Let's move to next question now. So in the next question, so this is a bit tricky and bit lengthier problem for today. So here, call this as equation number 1. So we'll proceed in the same way. So differentiating, you get with respect to x, obviously. So y1, y becomes y1. So here again you see a and b are the constants. So we'll try to remove them. Okay. So when you differentiate, okay, so first a is a constant. So okay, so differentiate x, you get 1. So keep cos log x as it is. Okay, now keep keep x as it is. Differentiate cos, it becomes minus sine, so that's why it will be minus sine log x into, now as per general you need to differentiate log x also. So differentiation of log x is 1 by x here. Okay, so this is the first part. Similarly, we'll do the same with this next part. So you get b into differentiate x, so you get 1. So 1 into, you get sine log x. Okay, now since you have differentiated x, now we will keep x as it is. Now we will differentiate sine. So differentiation of sine will be cos log x. Now since log x is there, so as per chain rule it becomes 1 by x. Okay, now we have x log x, so u into v you need to apply. So u into v, again differentiate x, so it becomes 1. So just log x is left. Now keep x as it is. Now differentiate log x, it becomes 1 by x. Okay, so x and x gets cancelled. Okay, now similarly here x and x gets cancelled, and here also x and x gets cancelled. Okay, so from here, see what do we get? We get y1 equals to a, so you have cos log x minus sine log x plus b sine log x plus, how much is left here? Cos log x is left, cos log x. Okay, so let me close it. So we are left with now log x plus 1. Okay, now we'll differentiate it again in the same way. So when you differentiate it again, now you get here the y1 becomes y2. Okay, now this is, okay, let me keep it as it is. So differentiation of cos is obviously sine, so it becomes minus sine, in fact, so minus sine log x. Now differentiation of log x is 1 by x. Okay, be careful with this. Similarly, this becomes 1 by x cos log x. Okay, plus we have b. Similarly, this becomes 1 by x cos log x minus 1 by x cos, I'm sorry, not cos, the differentiation of cos is sine, so it becomes sine log x. Okay, now this becomes, see here carefully, it becomes 1 by x, isn't it? So this becomes 1 by x. So let me write 1 by x here, 1 by x, and this 1 becomes 0, so I need not write anything out here. Okay, so this is my b. Now what am I going to do is I'll multiply both sides by x square. Why? You will understand this. See here carefully. So if you multiply with x square, you get x square y2 is equals to, now open the bracket also. Okay, so you get minus, so when you multiply with x square, x and x gets cancelled. Okay, so only one x is left, so you get minus ax sine log x. Similarly here you get minus a cos log x. Okay, by the way, call this as equation number 2. I have not written. Okay, so this becomes a x cos log x plus this becomes bx cos log x minus this becomes bx sine log x plus this becomes 1 by x into x squared is just x. Okay, now just look at this very carefully. Okay, now I'm going to use equation number 1. Okay, from equation number 1, let's see how much is this. Ax cos log x plus bx sine log x. So do we have ax cos log x? Yes, so we have ax cos log x out here. Okay, and similarly we have bx sine log x. Okay, so we have this one. So just look at these two. Okay, there is minus common, isn't it? So if you take minus common, let's see how much do we get. So others we will keep in one place. Okay, so we have, okay, so first let's write this. Okay, so minus is common, so you get a x cos log x. Okay, plus, so when minus is common, then this becomes plus, so bx sine log x. Okay, so others are plus x minus, now among this one and this one, you see something is common. X is common, right? So take x common, then this becomes, if you take x common, then this becomes b cos log x, b cos log x. Okay, minus we are left with a sine log x. Okay, so that's what we have now. Okay, now see, use equation number 1. Okay, use equation. Okay, so you, if you use this in equation, if you use equation 1 in this, okay, so from here this much will be y minus, you bring this out here, so y minus x log x, that's what you get. So when you, okay, so you have, this is y minus x log x, that's what we have. Okay, so we have plus x here minus, now just look at this. Okay, just look at this. So what am I going to do is, I'll be using equation number 2 here. Okay, I'll be using equation number 2. So from here, what am I going to do is, I'll just find what is b cos log x. Okay, what is b cos log x minus a sine log x. So b cos log x is there. Okay, so see here, just look at this carefully. So we have b cos log x, that is this one. Okay, minus a sine log x, so minus a sine log x is there. Okay, just keep it this much, and the rest will go to the right hand side, and let's check how much do we get. Okay, so we have x already here. Okay, so open the bracket, b cos log x minus a sine log x. So send everything to the right hand side. So we already have right hand, in the right hand side, y1. Okay, now this will go to the right hand side, that is minus, how much is this? This is plus a cos log x, so when it goes over there, it becomes minus a cos log x. Okay, similarly this is gone. Similarly, when it goes over there, it becomes minus b sine log x. Okay, fine, this is also gone. So when you take it out there, it becomes minus log x. When you take minus 1 over there, it becomes minus 1. So everything is taken. I hope this is clear. Right, now do we have, okay, first and foremost, let's open the bracket. So minus y plus minus into minus is plus x log x, okay, plus x, now open the bracket, minus x y1 minus into minus plus ax cos log x, minus into minus is plus again, so bx sine log x, okay, and we have minus x into minus into minus is plus, so x log x, right? So we have x log x, and we have finally minus into minus plus x, right? So we have plus x. Now look at this carefully. Just look at this much. Just look at this much till here. Okay, so see, look at equation 1 and just look at this much. Can I call this to be y? Definitely, right? So before that, okay, so before I call it y, okay, so yes, all right, is this clear? Okay, so do we have any problem with the sign? No, we don't have any problem. Okay, right, so we have, this is equals to, this is minus y plus we have x log x, this is x plus the last x is 2x, okay, so we have minus x y1. Now how much is this? From equation 1, this is exactly y, isn't it? So this plus y and minus y gets cancelled. Okay, so if you want to bring it to the right hand side, that can be done. Okay, so if you want to bring it to the right hand side, that can be done, or else if you want to leave your answer to be like this, that is also fine. So from here, what do you see? You see that x square y2 is equals to x log x plus 2x minus x y1. So this is the required differential equation. So initially only I told you that this sum is a bit tricky or lengthy, so you may pause the video and note down your solution here. Okay, so we have yet another question. So here what you need to do is, so the first part says verify that all the circles that touches y-axis at the origin are included in this. So you need not do this particular problem because this is a part of your class 11 mathematics coordinate geometry, so just forget about it. So using this equation, that is given is x square plus y square is equals to 2cx. So how many constants are there? You see only one constant is there. So from here you arrive at the differential equation. Okay, and you need to show that the required differential equation is this much. Okay, so you will try this by yourself. Okay, so you may pause the video and note down the question. So we have yet another similar kind of question. So you need to show that this is a solution of this particular differential equation. You see a and b are the constants, so that's why the resulting differential equation will be of second order. You can see your answer on the screen, isn't it? So you may pause the video and note down the question for you. Okay, and with this we close this particular topic of finding the differential equation when the solution is already given to you. Okay, so with this we close. Thank you very much.